Okay, so welcome back to another video. In today's video we have the following proof. We want to prove that the for all real values x and y, that the following inequality holds: x squared plus y squared is greater than or equal to 2 times x times y. And this video is just going to be really short. This is, I like to call this like a baby proof. Especially a proof like this is actually perfect for anybody that's taking some sort of introduction to a proof writing class. Classes like those that just teach you, for one, how to write proofs, but you start with the basics on how you deal with just like any sort of numbers. Eventually helps you build up when it comes to writing stuff for like maybe when you get into like an analysis course or, you know, algebra, PDEs, or like any sort of like higher advanced level mathematics, just to get you up there. So this is like the basics. So the proof is very simple, really. It's all about just using algebra and then analyzing like the behavior of what our real value x and y do with this inequality. So of course, anybody who hasn't taken a proof writing class, or if you're in that lower standard, you can't just do it for one number. Obviously, that'd be like too easy to show and that'd be a little trivial, obviously. But you want to show for all real numbers x and y works for the following inequality here. So that's what this is. That's to help to get you started if you're learning how to write proofs in mathematics. So anyway, let's actually just jump right ahead. So I'm just gonna write what we're given. So x squared plus y squared is greater than or equal to 2xy. And of course, we're given that we want to show that for all x and y for the reals is that this satisfy the following inequality over here. So let's actually do a little bit of rewriting of this side. So I'll subtract 2xy to both sides. So we have x squared minus 2xy and then plus y squared. Simply, we still keep the inequality, and that's actually just going to be 0 on the right hand side. Now notice what I can do is that I can actually rewrite this using, well, we could factor this out from the binomials. So this comes out to x minus y, and then also x minus y as well, greater than or equal to 0, which you can see if you want to verify, you can actually use the FOIL method and see that it works. So in other words, you can actually rewrite this as x minus y squared is greater than or equal to 0. So this is where we have so far. But we want to prove that all x and y are for the real values satisfy the following, or in this case, satisfy the following here, since we did a little bit of rewriting. But think about x and y. You know, for all real values, there's also the possibility that you also have x being a positive or y being a negative, or vice versa. So you need to think of some cases of what's going to happen with how the inequality will behave with those values. So in this case, this is where you're going to learn in some proof writing, in the proof writing class, about cases. So in this we have two cases that we want to show. So the first case is that we want to analyze the behavior that what if x is actually greater than or equal to y, and then the second case, what if so case 2, what if x is less than y. This is actually very easy to see and then analyze once I jump into the first case and the second case eventually. So here's what we want to pay attention to. X is greater than or equal to y, right? So what I can do is I can actually just subtract y to both sides, right? And so that means x minus y is greater than or equal to 0. This entails that x minus y has to be, it can be equal to 0, or it can be it's a positive number. So think about it this way. What happens if I were to square both sides of the equation? So if I were to do this, well, you don't really have to do this step, because it's very obvious to see what happens that if you square a positive number over here, the result is that you're going to get a positive. So squaring both sides, that means x minus y squared. This is still 0. You see that this is a positive number, but it also can be equal to 0. So we satisfied this following statement over here. So case 1 has already been shown. So let's show the the second case over here. So x is less than or y. Okay, so x is less than y, so I'll subtract y to both sides of the inequality. So x minus y is less than 0. This entails that for this, if x is less than or y for all x, y in the reals, I should also say that for the other case as well, x minus y for this situation over here is supposed to be a negative number. So what does that mean? So what I can do is that if I were to square both sides, x minus y square, this means that squaring all negative numbers is actually going to turn out positive no matter what. And if that's the case for over here, then that means this would change the inequality sign to a greater than, strictly greater than, and this is still 0. And basically, that's the proof. We've shown the two following cases verify such that the inequality holds. Therefore, we can say that x squared plus y squared is greater than or equal to 2xy, like so. And there we have it, proven. So yeah, that's pretty cool if you ask me.